I have an interesting case of a woman with mitral valve stenosis, so I want to go over how to evaluate for mitral valve stenosis and its severity. So here is a close-up of the mitral valve. You could see immediately that there is diastolic doming of the mitral valve apparatus. So if I were to draw it out here, here is diastole, and you could see this hockey stick shape of the anterior leaflet and somewhat of the posterior leaflet. What clues you in to the fact that there may be some level of stenosis is that right here in diastole, there's a lot of turbulence. So not much MR to speak of, but here we are in diastole. There's turbulence, whereas we're used to seeing turbulence in colorful flow. In systole, here we are having it during diastole, which indicates to you that the mitral valve diastolic flow is going through a very small orifice. Here you see it again, the turbulence. Mitral valve on M mode. Don't think we see the valve quite closely enough to be able to get that classic M mode across the mitral valve. The aortic valve, however, is opening quite well. Short axis across the level of the aortic valve. Let's see if we can have one across the mitral valve. Here we go. A lot of turbulence here. Mitral valve does not open very well. Aortic valve, on the short axis view, everything is moving quite well. We do have reasonably elevated pulmonary pressures. At one point we got levels in the 50s, so I estimated to be about 53, which is moderately increased. The 4-chamber view, you can see that the LA is actually quite big. I got an indexed area volume of about 55 milliliters per meter squared, so that's consistent with severe LA enlargement. So moving on to the mitral valve and its flow. Here you see in diastole here, a lot of color turbulence. The Nyquist limit here is 60, so we're not actually overestimating how turbulent the flow is. So this is pretty consistent with what mitral stenosis wave Doppler should look like. Again, I'll show you here. The LA volume turned out to be 118, index to about 55. Here is the diastolic flow across the mitral valve. The tech is getting numbers anywhere from 10 to 16. So I will do one measurement myself just to make sure that you're not measuring the hairs. We kind of just want to measure the solid parts. So I'm going to show you how I would measure it. Mitral valve diastolic mean gradient is the one you would choose. Here. I'm going to cut out all the hairy, fuzzy parts and just focus on this. So now we're getting a mean gradient of about 7.7. I got a little bit higher numbers later on. So here, we'll try this one. Again, cutting out the hairier parts. Getting numbers, about 8.6. That'll make us make it the criteria for severe mitral stenosis. When you're reporting mitral stenosis and the mean gradient, make sure that you're always adding the heart rate, because if somebody has a very high gradient at heart rate of 100, the treatment would not be for surgery or valvuloplasty, but rather to decrease the heart rate, because once you decrease the heart rate, so too will your mitral valve gradient. So another important thing is to measure the pressure half time. In this case of mitral stenosis, you tend to want to measure the pressure half time in CW rather than PW. So I will do it here. Mitral valve, okay. There's a little decel time symbol. We'll do it here. I just want to show you how disappointing that the mitral pressure half time is. So let's do the calculations. As you know, pressure half time is 0.29 multiplied by the decel time. So 102. And now if you were to plug it into the mitral valve area equation, it would be, let's remember this number, 102 or 103, let's make it 220 divided by 103. Give you a mitral valve area of 2. I'm pretty sure this mitral valve area isn't 2 and that this pressure half time is underestimated. So in this case, I don't think I would use it because I actually think there's moderate, if not severe, mitral stenosis. Okay, moving on. The mitral valve seen here on 2-chamber. A lot of turbulence again. The aortic valve looks fine, and so too are the gradients. Again, I would probably measure it a little bit here, cutting out the hairs in here. Okay. And finally, looking at the subcostal view. Fair amount of TR. Actually, maybe not so much, mild or moderate, so. In the IVC looks large but collapsed. And one other thing that may be of use when you're doing a mitral stenosis study is to do a PW here, not at the mitral valve tip, but at the mitral annulus. And the reason is that we can use this mitral inflow here in the continuity equation to get your aortic, get your MVA. So what you can actually do is multiply your aortic valve area multiplied by your LVOT outflow. Divide that by the PW of the mitral inflow that you get here, and theoretically be getting your mitral stenosis valve area. It's a very rough way to do it. It's not always the most accurate, but it's just another piece of information that may be helpful to you.